Good evening. I'm Spot On Weather meteorologist Matthew Euler. Welcome to my latest video. This is going to be a forecast update, the latest update as of the 5th of January 2024. And, we're in early January now. This is the time of year where we may start to see scenes like the one you're seeing here on the title slide tonight. Bunch of fun going on here, snowballs getting thrown at each other. The boy over here on the left, he's got a big snow ball rolled up here. Looks like he's trying to make a snowman. Hopefully he's not going to put that big snowball on top of somebody and surprise them from behind. Growing up in the Midwest, I remember a lot of fun times like this in the winter. I remember times where, of course, the snowball fights, but then, also kind of like sneaking up on people from behind and grabbing a handful of snow and putting it down the back of their shirt. There's nothing that really gets people going when you like that. So just a lot of fun times growing up, and you live in the mid-Atlantic in the eastern U.S. It's been a fairly scarce season to this point so far in the winter. We're going to take a look at some factors here in this evening's video that might change things a little bit for the mid-Atlantic and the eastern U.S. as a whole. So let's go ahead and get into tonight's video discussion. The overview of the video, I'm going to cover the update on the stratospheric polar vortex. We'll take a look at the latest QBO, the quasi-biennial oscillation. We'll look at the latest sea surface temperature anomalies, the teleconnections. We'll look at the Pacific North American pattern, the PNA, the North Atlantic Oscillation, NAO, the AO Arctic Oscillation, the EPO, the Eastern Pacific Oscillation, and MJO, Madden-Julian Oscillation. And then we'll look at some of the modeling, what we're looking at here in the future, what some of the modeling is indicating, and then my final thoughts to conclude the video. So let's start things off this evening with a look, the latest update on the stratospheric polar vortex. And if you look what's going on here, this is the zonal mean zonal wind at about the 10 millibar level, well above the ground, above 60,000 feet at about 60 degrees north latitude. We measure the strength of the stratospheric polar vortex based on the zonal mean zonal winds. So across the bottom of this diagram, you see the date, the month. So 01 is January, and then this last two digits here on the bottom x-axis here, this horizontal axis, the last two digits are the day of the month. So right now we're sitting at January 5th, 0105. You see the white vertical dashed line here. And you can see what's going on with this stratospheric polar vortex, okay? Whenever these winds drop off and drop overall magnitude, here, by the way, over here is the vertical axis indicating the zonal mean wind speeds in meters per second. But whenever these lines, these are different models. Each of these lines represent various models, and I'll show you what models these represent on the next slide. But whenever we have a dip or a decrease in the zonal mean zonal wind speeds, that is indicative of a weakening polar vortex in the stratosphere. So we see a major drop-off from the last day of December, right on New Year's Eve, a significant drop-off in these zonal mean zonal winds in meters per second, and a further weakening here on the 5th of January. So we've gone from about 40 meter per second wind speed all the way down to about 11 to 12 meters per second wind speed at this particular level in the atmosphere, the 10 millibar level above 60,000 feet above the ground and at 60 degrees north latitude. So a major drop-off in the wind speeds in the stratosphere, and that is coincident with a weakened stratospheric polar vortex. Now, if we look into the future, notice how these different color lines, the different models kind of vary in what they're thinking is going to happen with these zonal mean zonal winds now. There's a little bit of strengthening indicated between the 8th and the 10th of January, but then it kind of levels off between the 10th and the 14th before another drop off in the zonal mean zonal wind speeds. See, most of the models are showing this dip. The green line here, that particular model, and I'll show you again what models these are in a minute, but that particular model is not as robust as, say, the other three models, showing a major drop-off in those zonal mean zonal wind speeds just after the 15th of January. Before there's a slight increase in those zonal mean zonal winds again as we approach the 20th of January. So overall, a weakened stratospheric polar vortex. It's evident with weaker zonal mean zonal winds at the present time on the 5th here of January 2024. And then again, a secondary weakening, another drop off in these zonal mean zonal wind speeds is expected just after the 15th of January. So vortex situation, look here on the right. This is as of today, the 5th of January, 2024. These white solid lines represent height contours. We are looking on this particular graphic here on the right at the 30 hectopascal or 30 millibar level. Not quite the same level or altitude as what I'm showing you here on the left with this 10 hectopascal level diagram. But this does show you the stretched out look. These white solid lines, the height contours, you notice how they're kind of elongated, right? Shaped more like an egg, right? And so you see blue coloring indicating below normal or colder than normal stratospheric temperatures. The orange coloring is indicating well above normal stratospheric temperatures. So whenever we get stratospheric warming events, you're going to see some of these orange colors really stand out. But we have a stretched out polar vortex as of today, the 5th of January, 2024, stretching basically out the axis from Europe, the Europe area right back to the Canadian Maritimes. Now, let's take a look and examine the temperatures in the stratosphere, okay? So, in order to get a major sudden stratospheric warming, you may have heard this before on social media or on the TV or in the news, you need these wind speeds to drop below the zero line. That would constitute negative values or a switch in the wind direction in the stratosphere to easterly. The positive values represent westerly winds in the stratosphere. The negative values represent easterly winds in the stratosphere. So when you have a really strong stratospheric polar vortex, this value, this wind speed is much stronger, very much more robust as far as westerly winds in the stratosphere at 60 degrees north over the pole area. So just wanted to point that out. Let's move forward now. All right. By the way, these are the different models. So for example, the orange line on this forecast is the GFS model. The lighter purple colored line is a GEOS. The green solid line is the Jeffs Ensemble average. The light, like this very light blue color, is the CMC Jeffs Ensemble average, and so on. So various models here. Now, what happens here? Okay, I was kind of explaining this from the zonal mean zonal wind graphic here. If these winds drop below in a negative value territory, we have what's known as a major sudden stratospheric warming. Right? They have to drop into the negative values and switch direction from westerly to easterly. And you see here what we had going on from the end of December. Look at this steep climb. This is a significant climb. Here are the temperatures on the left. See this from 205 to 235 Kelvin temperature values. Look at the steep rise or warming of these stratospheric temperatures. Here we are on the 5th of January, and those stratospheric temperatures, the warming is peaking today and tomorrow, the 6th of January, before we see a drop-off or a cooling of those stratospheric temperatures between basically the 6th of January to the 12th of January. We're going to see a cooling of those temperatures. But then you notice there's a little bit of a slight warming that's occurring right here. That'd be 11, 12, 13. That'd be between the 13th and the 15th of January. We have a slight stratospheric warming again here, up to about 225 Kelvin stratospheric temperatures before things either level off or kind of cool off again per the model forecast. So you notice how these temperatures increase here, right, between that 13th and 15th of January. Let's look at the zonal mean zonal winds. What do they do at the same time? They increase slightly. And then they drop off after the warming. So just wanted to show you that. So we have a stratospheric warming right now that is peaking, and then the temps are going to cool through the 12th of January before another slight warming occurs. And over here on the right, I'm showing the same graphic I showed in the last slide. So white solid lines are your height contours. Yellow color indicates warmer than normal temperatures in the stratosphere. And then you got blue coloring indicating colder temperatures in the stratosphere, okay? So in general, what happens by the 17th of January, okay, so we started here on the 5th of January, you can clearly see the elongation or stretching of the vortex. And then by the 17th of January, we still have an elongation of the vortex, extending from northern Europe there, around Scandinavia, Norway, Sweden, Finland area, working its way towards the southwest, towards the eastern portions of Canada and into New England by the 17th of January. I'm going to show you what that's going to do to our temperatures here shortly. Let's move on now to the quasi-biennial oscillation update. This was the radiosonde radiosonde observation, the zonal winds in meters per second from yesterday, the 4th of January, 2024. This is the latest I could pull today. Anything to the left of this gray vertical line here is indicative of easterly QBO. So what do we got going on when we say easterly QBO? We generally have a negative value to the zonal winds, okay? And this typically occurs above the equator now. We talked about the stratospheric polar vortex being over, 60 to 90 degrees in the North Pole area. When we talk about the QBO, we talk about an oscillation or a change in wind direction between easterly, where the values are negative. We have easterly winds in the stratosphere above the equator versus westerly. And if we had a westerly QBO, we'd have more positive values, zonal mean, zonal winds over here on the right. So right now we have a negative or easterly QBO where the winds are blowing from the east above the equator in the stratosphere. Now, why is that important? Because it contributes to a weaker stratospheric polar vortex, and it's been doing this already this winter. We have not seen a very strong polar vortex in the stratosphere so far this winter, and I really do believe, based on past research that's been conducted by a lot of great professionals out in the field, I believe that this QBO is definitely a major contributor to the weaker stratospheric polar vortex. If we look at the current value, no new update over here on the right. We're still sitting at minus 19.80 for the QBO value. Okay, no new update yet. As soon as I get one, I'll be sure to share it with everybody. Here again were the El Nino winters of the past: 0910, which is the gold standard for winter weather in the east, and then you have 2015-16. So you can kind of compare the values. Remember, 2015-16. We had a westerly QBO or a positive values over here on this chart. The blue line would be over here in the positive area, and it'd be a westerly QBO where the winds are blowing from the west in the stratosphere above the equator, okay, as compared to 0910 where we had also had a negative or easterly QBO. Let's take a look here, just a couple samples of why the QBO matters to the stratospheric polar vortex. First of all, this is pulled, these bullets are pulled strictly from research, which I'm sharing with you the authors' names and the years. First of all, the QBO and the stratospheric polar vortex. The QBO overall influences the strength of the stratospheric polar vortex. And why is that important? Because it tends to influence our tropospheric or our surface weather patterns, our pressure patterns. Easterly QBO phase is also associated with a weaker stratospheric polar vortex, as I mentioned in the previous slide. Now, this was research conducted by Anstey and Shepard back in 2014. The easterly QBO also coincides with more sudden stratospheric warming events. And we haven't quite reached that major sudden stratospheric warming category, right? We have these values right now in the fifth are still in the positive territory. They haven't dipped below this white zero line here, this horizontal line. So we have a warming, yes, it's a minor stratospheric warming, but easterly QBOs can also coincide with more sudden stratospheric warmings, a weaker overall Atlantic jet stream, more meridional in nature, and a cold winter in the eastern U.S. So this is why it's so important that we take a look at this winter, this easterly QBO and the stratospheric polar vortex relationship. If we were in a westerly QBO phase, okay, very similar to 15-16, that would be associated with a colder, stronger, more symmetrical shaped stratospheric polar vortex. And this was, again, demonstrated by research conducted by Anstey and Shepard in 2014. And what does a stronger, more symmetrical stratospheric polar vortex do in association with westerly QBOs? What does it do? It produces milder winters in the eastern U.S., stronger Atlantic jet streams, more of a zonal west to east kind of configuration to the jet stream. All right. All right, let's move on. Let's take a look now at update on the latest sea surface temperature anomalies. All right, so anything in the orange coloring indicating well above normal sea surface temperature anomalies. Anything in the blue shading is below normal sea surface temperature anomalies. So, big thing here on this particular graphic, and I'll go ahead and draw it out. We have the continuation of El Nino right here. Very much so. And I'm going to break down the regions here in a moment on the anomalies, but very warm across this equatorial eastern and central Pacific associated with El Nino. We still have the above normal water temperatures also in the northwestern Pacific. A little bit of cooling recently here in the Gulf of Alaska right into the northeast Pacific. Surprisingly here from basically Massachusetts down to the mid-Atlantic coast, it's actually below normal temperatures as indicated by the blue coloring. And then another area that's above normal in the sea surface temperatures is the western Indian Ocean. So we have a lot of things going on here that we examine. Why do sea surface temperature anomalies matter? Really, they matter because wherever these set up, these could favor various synoptic pressure patterns to set up the jet stream to take on certain configurations. So bottom line, El Nino is continuing. Let's examine the Nino regions now. Nino 1+2 area or region. Right now we're sitting at a positive 0.77. I mean, look where we started. Positive 2 back in November 10th. And now we're only at positive 0.77 degrees Celsius above normal in accordance with Nino 1+2 region. And you can kind of see where the region is here. It's right off the coast, the west coast of South America. Additionally, Nino 3, we're looking at a fairly steady state to Nino 3 region, sitting at a value of positive 1.767 degrees Celsius above normal. But overall, you notice it's pretty much a horizontal line here from October to the present time. Let's examine now the Nino 3.4 index here, situating right now the latest value of Nino 3.4 region, which NOAA uses to classify the El Ninos, the ENSO state. It's sitting at plus 1.619 degrees Celsius above normal in Nino 3.4. And then finally, the Nino 4 index, what are we looking at for ONI, Oceanic Nino Index? Positive 1.28 degrees Fahrenheit Celsius, 1.2 degrees Celsius above normal. All right, what does this mean? Okay, first of all, let's take a look at this. Why do we even care about looking at where the warmest sea surface temperature anomalies are located when we're talking about El Nino winters? Okay, the main reason is because we generally tend to see whenever we have the warmest or greatest sea surface temperature anomalies in Nino 1+2 and Nino 3 here in the upper right, that's associated with an east-based El Nino. Whenever we have the warmest temperature anomalies out here in the Nino 4 area, that's associated with a central-based El Nino. And that sets up very different results across the United States. In both cases, we have wetter than normal conditions across the southeast and mid-Atlantic in El Nino years. But the temperature distribution is slightly different. When you get an east-based El Nino, you generally have milder temperatures in the eastern U.S. winter. If you get a central-based El Nino, you generally have colder than normal temperatures in the eastern U.S. So that's why we take a look at it. Right now, based on these values that we just looked at, the Nino 3 region is basically the warmest region at that value of plus 1.767 Celsius above normal. All right, now let's take a look at the teleconnections, and we're going to start with the Pacific North American pattern. This is the European EPS PNA 50 perturbed members 15-day forecast, starting at 00Z the 5th of January today, going all the way out to 00Z on the 20th of January. The green line is the one I pay most attention to because that's the average of all these various ensemble forecast members, the 50 perturbed members. The green line represents the average of all 50 of those members. All right, so what are we looking at here? For the PNA, Pacific North American pattern, we have a negative trend to it. The solid green line here, the ensemble average, it stays negative all the way to the 18th of January. This would indicate a milder situation. I'm going to put a plus sign. This would favor a trough in the western U.S. and a ridge in the eastern U.S. This would favor positive or above normal temperature values for the east. This is the European EPS, PNA, 50 perturbed member, but now we're going to go out 46 days on this outlook for the PNA forecast. Notice how negative the PNA is as we head from the 6th to the 11th of January. But then look what the EPS, the longer range EPS is showing. We're going into positive territory here. We're going from a negative value, to a positive value, negative PNA to a positive PNA over time. Specifically, after the 26th of January, we would go negative to positive on the PNA according to this model. Now, that would favor above normal temperatures in the trough in the west right on through the 26th or so, 25th, 26th of January, and then we would see higher heights over the western portions of North America after the 26th of January through mid-February, which would be indicative of colder than normal temperatures and troughing in the eastern U.S. Here is the Jeff's V12 PNA 30 perturbed member forecast showing a negative trend throughout. This thing doesn't even get above positive on this particular forecast model, the Jeff's V12 for the PNA. This would indicate a continued favoring of the trough in the western U.S. Here is the North Atlantic oscillation now. Now this one's the big player right now, folks. look at the values here of this negative NaO. It goes down all the way to -3 at its peak. And the PNA also goes down to a value of -3 at its peak. Okay, so we got a real battle going on, because what does a negative NaO do for us? In the eastern US, a negative NaO favors colder than normal temperatures, while this negative PNA favors warmer than normal temperatures in the east. So we have one teleconnection telling us, hey, the negative PNA, it's telling us it's going to be milder in the eastern US with ridging, while the negative NaO is telling us, nope, it's going to be a trough and colder in the east. And so there's some destructive interference between teleconnections that's occurring. If we look at the NaO, the European EPS, 50 perturbed members, now this is the 46-day outlook well into mid-February and beyond, showing a very sharply negative. I mean, this thing almost goes down to -3.5 in the value. So very strongly negative NaO before it starts climbing. Now, why is this so important, this area where we start seeing that green line climbing back closer to zero, back to neutral? Because Cosin and Uccellini from the Northeast Snowstorms Volume 1 book generally discovered in their research that East Coast winter storms generally are favored in a time period when the strongly negative NaO starts to work its way back to neutral conditions, this transition part from strongly negative on up towards neutral. This is a zone, 16 to 21 January, folks, and I want to mention it again here in the video. Watch this time period closely for a potential East Coast storm. Here is the NOAA JEFS V12 NaO 30 perturbed member forecast going out to 21 January, showing also a negative trend of the NaO, deeply negative, down to a value of -3 at this point at its peak. And then we see that climb again right here. See this? That right there, according to the JEFS V12, we would be looking at the period from the 15th to the 18th of January for a potential East Coast storm. Now, what happens when we look at, okay, so let's just take a look at El Nino alone here. This is the top chart right here. We just look at El Nino's influences alone on winter temperature anomalies. The blue shading is colder than normal. The orange shading is above normal. So we look at just El Nino winters of the past. The analog shows colder than normal temperatures from Texas across the deep south, the Gulf Coast, up to the mid-Atlantic. A near normal temperature is just north of that. And the warmest temperature values during El Nino from the analogs are well up into Canada. Now, if we take into account both the El Nino and the negative NaO here in the middle, now you notice this blue coloring is much darker. So that means we got much colder temperature anomalies, well below normal anomalies across the southeast and mid-Atlantic when we combine El Nino and a negative NaO. Okay, and then finally, if we have an El Nino and a positive NaO, what happens? Oh wow, there's a lot of warmth going on across western Canada, right into central Canada, into the northern plains, Midwest. It's very mild across the United States. It's also very mild across Europe when you combine El Nino and positive NaO. So this is why I keep emphasizing when you combine a couple teleconnections, this is called constructive interference, where they're working in the same direction, they're amplifying each other, okay? And what do we have? We have El Nino winter. We talked about it, right? We have El Nino going on, right? I'm showing you the water temperature anomalies here. We looked at that, and we have a negative NaO, all right, on all the models right now, at least through about the 20th to 22nd of January per the latest models. So we have a negative NaO, and so we're right here. We're right in the middle here. We're right in here. This is what we should see with a negative NaO and El Nino together. We should see the lowest temperature, the coldest temperatures, the greatest temperature anomalies in the southeast up to the mid-Atlantic. Let's examine and see if we actually have that here in a few minutes. We will look at the modeling. So here's what happens now when you take a negative NaO and you combine it with a negative QBO. So now I'm doing the QBO in a negative or easterly phase and the negative NaO. All right, this data is from 1981 to 2010. So the graphic here on the left is 1981 to 2010. These are some reanalyses. Look at your cold air. It's basically from the Midwest to Minnesota, Iowa, Illinois, Missouri is where the coldest values are, but that cold kind of bleeds southeastward towards the East Coast when you have a negative NaO and a negative QBO. What happens now over here on the right? We're looking at, let's see, this is the 500 millibar composite. These are geopotential height anomalies. December to February. Now, some of the years that we had a negative NAO and a negative QBO were 2010, in 1977, 75, 63, 57, 09, right in here, okay? Look at what we got here, folks. Look at this. We got extremely lower than normal heights across, working its way into Europe, and we have very much below normal heights across the Midwest and the eastern U.S. as a whole. Not much warmth. The above normal heights when you have a negative NAO and a QBO are well to the north here over Canada, or even well north of that, rather, in over the Arctic area. Let's now move on and look at the teleconnection, the AO forecast teleconnection. And this is the EPS AO 50 perturb members. This goes out to the 20th of January. Look at the solid green line here. That's the average of all 50 of these perturbed members or models. We are negative, and we are more sharply negative with time. We're bottoming out with the AO on the negative side between the 15th right on to the 18th of January. And the AO, the phase or sign of this, whether it's positive or negative, is a direct reflection of the strength of the stratospheric polar vortex. When the stratospheric polar vortex weakens, we get strongly negative values. So it makes sense. We have that right now. If this were to be, let's say the AO was positive up here, that would be indicative of a stronger stratospheric polar vortex. We don't have that right now. Here's the AO European EPS 50 perturb member forecast. This one goes out 46 days all the way beyond mid-February, and we go really negative on this model all the way almost down to a value of -4 is where it bottoms out the AO, and then it starts to transition back up, but then it's still remaining negative even further down range here. 1 to 6 February negative AO, all the way out to mid-February a negative AO. Now that would favor colder temperatures in the eastern U.S. And then finally, the Jeffs V12 AO 30 perturb member forecast. We are negative. Look at the green line. I'm in negative values the whole time, right? All the way out to the 21st of February. And finally, the EPO Eastern Pacific Oscillation teleconnection. So when we get a negative phase of the Eastern Pacific Oscillation, we basically have a ridge, a high pressure over the Gulf of Alaska with lower pressure beneath it. That's a negative phase, the EPO. That allows a ridge to build up into Alaska. That allows cross-polar flow to get established where we get really cold air from Siberia. You may have recalled back in December, it was extremely frigid in Siberia. They were setting all-time record cold temperatures. Even into China, they were doing that. And why was that? It was because we had a positive EPO where we had a strong Aleutian low pressure system in the Gulf of Alaska over a high pressure system in the Eastern Pacific. And that resulted in more of a west to east jet stream, which didn't allow that cross-polar flow to occur with a positive EPO. So right now, we're situated at a positive value of the EPO today on the 5th of January, 2024. And then we take a hard nosedive here right at the 10th of January, all the way out to the 19th of January. We got a negative EPO. That's going to be that building of the ridge on up into Alaska. I'll show you some ensembles here in a moment, and you'll see what I'm talking about. Let's take a look at the EPO 50 perturb member. This is European EPS going all the way out past mid-February, 46-day forecast. Again, we start off positive today on the 5th of January, but then we work our way to negative, and then we go back to negative generally around the first week of February. And then finally, the NOAA Jeffs V12 EPO 30 perturb members all the way up to 21 of January. We're starting positive again, where we got, the low pressure, lower heights to the north of the Gulf of Alaska over higher heights to the south. But eventually that EPO goes negative here, according to the Jeffs V12, the 10th, and it goes all the way out to the 21st. All right, so now let's discuss the MJL. The Jeffs V12 bias corrected, right? We're sitting basically around this point right here. We're in phase 3 of the MJL according to Jeffs V12 today. What's going to happen over time is it works its way closer to the null phase, but then it takes a hard right turn and goes out. This is important. It's going out to phase 4. Uh-oh. That's a warmer phase, folks. All right, if you want cold temperatures in the east, you want it in phase 8, 1, and 2 over here. Not on this side. That's the warmer side of the MJO phase diagram. All right, what about the European bias corrected on the latest here on the right? Very similar. All right, they match up fairly well for the 5th of January here, the number 5, and then they loop, it goes towards null around the 9th, but then it comes back out and loops back towards phase 4 and then into 5 by the 19th. And one other big thing, yeah, they're about the same, the magnitude as well as the rotation. Now let's just play hypothetical games here. Let's say now, instead of going back to the right out this way, this decides to go into the null phase. Okay, let's say that the MJO goes right into the small inner circle here, null phase. When I say null phase, I basically mean the MJO, the tropical convection, has little impact on our weather here in the US. That is going to result, if this were to go in the null phase, that would result in extremely cold temperatures moving east for sure. I'm a little concerned about this, guys. I'm a little concerned about heading to, 4 and 5, these phases here. Why am I concerned? If we look at the temperature composites, blue below normal temperatures, orange above normal, what happens, when do we want the cold? Cold is blue, the blue color is cold, so if I really want cold east, I want phase 8, I want phase 1, I want phase 2, and even phase 3 this time of year can give us cold temperatures over much of the United States. But if I start rotating now into phase 4, look at this orange coloring in the eastern US. Above normal temperatures, milder. If I get to phase 5, which, go back here, it was showing possibly going to phase 5 on the 19th of January. Oh no, not good for the eastern US, not good. I'll put a red X there. Look at all this warmth, all this orange coloring in the mid-Atlantic. It would be a very mild pattern if that were to occur, or it would support a milder pattern anyway. Doesn't necessarily mean it's going to happen. Now, I wanted to just I wanted to go back to the 2009-2010 winter season, and I really wanted to take a look at this time of year back in 2010, in January. This diagram here, the MJO diagram, actually goes out to March 2010. But I wanted to do this purposely because we have 3 things that are very similar to 09-10 winter season going right now. We have the El Nino. I don't know why it keeps spiking like that, I apologize. So we have the El Nino, we have the easterly QBO, and we have a weaker stratospheric polar vortex. We have all of these going on right now in 2023-24 winter season, very similar to the 2009-2010. So what in the world was going on with the MJO back in, let's say, from January 1st, 2010 to March 31st, 2010? Okay. The blue line, or the green line, I'm sorry, no, the blue line, I'll get it right. The blue line here represents the month of March. I'm not really as concerned about that. I want to focus in on the green line, which is February, and I also want to focus in on the red line, which was January. All right, so there are some similarities to the MJO forecast as far as what phase of the diagram things are located. Let me draw this out here. Okay. Okay. All right, so the red line represented January 2010. Now remember, 09-10 was the last moderate slant, weakly strong El Nino, plus again easterly QBO, plus the weaker stratospheric polar vortex. Now look at this. Right in the 7th to about the 13th, about the 15th of January, the MJO went into the null phase, a small inner circle here, and then it came out just weakly, very weak in magnitude, into 5 and 6, and then it came out into 7 at the end of January back in 2010, and then it took off. And look at the green line here. This green line indicates February. It went into our favorite cold phase of the MJO 8 before turning back into the inner circle here, the small inner circle, the null phase. So we have a similarity this January. We are seeing the same direction of the MJO, except the models right now, whether we look at Jeff's or European, it's stronger in magnitude. It's out here, which is going to have greater impact from the tropics, as compared to 2010 in January and February, where it kind of rode this small inner circle, the null phase. It was weaker in magnitude, basically, less influence. But I do like the fact, it'll be interesting to see if February, if this rotates back around towards 7 and 8 before going in February. So I just wanted to show you a comparison here. Now let's start examining some of the modeling now. All right. We are going to be in the mid-Atlantic in a very stormy pattern, very active pattern. We're going to start by looking at the latest 12Z European run from today, the 5th of January 2024, and we're going to kick it off here with the thickness chart on the left. Anytime you see the blue dashed lines on a thickness chart, that's lower thickness values associated with colder temperatures. Whenever you see the red dashed lines, that's indicative of higher thickness values and warmer temperatures. So if you want cold and you're looking at a thickness chart, you want to look for these blue dashed lines. All right, so what we got going on, this is going to be on Tuesday evening, the 9th of January, this next Tuesday. We're looking at a 980 millibar beast of a low, very low central pressure over northwestern Ohio. We're going to have a very strong front that's going to be extending basically down the spine of the Appalachians, western North Carolina, right through Georgia, and down through southern Mississippi and Alabama. We are going to have a huge slug of moisture right here coming up the coast. We're going to be in the warm sector. We're going to have a very strong south-southwesterly wind paralleling the surface cold front here to the west. This is going to result in a lot of wind. This is going to result in potential flash flooding of low-lying areas, probably a good bullseye of 2 to 4 inch rains across the Carolinas into Virginia for this Tuesday evening, the 9th of January 2024. We got a major storm system. Back in the Midwest, in these, you see the blue dashed lines here on the back side of the low, we have snow. Here are the temperature anomalies on the right, and you can see the maroon and the orangish colors. These are above normal temperatures because we're situated in that warm sector of the cyclone or that storm. So all the way up the eastern seaboard, forget about it. We're not going to have much in the way of winter weather with this system. We see the green colors and the blue colors out here over the desert southwest and Texas and the parts of Kansas and Oklahoma. That's well removed from the moisture in this case. So heavy rain and potentially damaging winds could occur along the eastern seaboard on Tuesday, the 9th of January 2024. This is something to watch. We're going to get a nice surge of southerly winds, which is going to really elevate or cause those air temperatures to rise to above normal levels temporarily, probably low 60s for southeast Virginia, I'm thinking. Now, the next storm comes in, Storm 2, on the 13th of January. Now, this was from the European run this midday at 12Z, 5th of January 2024. Now, this is where I think this one bears more watching as far as wintry weather potential as compared to the first one, the 9th. The 9th, that's a soaker, man, all the way up the coast. But this 13 January system, we have 2 areas of low pressure per the European for the 13 January system. We have over southwestern Ohio, we have a 988 millibar low. We have some energy transferring from that low to a newly developing low, a 986 millibar low over DC. We have a very strong Arctic cold front now extending southward from the low around the Maryland, DC area. Up here to the northwest of the low, you very well could see some pretty decent snow. Western PA, western New York State, even working its way, a rain to snow changeover for parts of eastern PA. But again, you're going to have a lot of rain from the northern North Carolina into Virginia out ahead of the system. Here is the temperature anomalies on the right. Look at this maroon orangish coloring going up the southeast coast of the mid-Atlantic coast of Virginia. This is well above normal temperatures. That's going to result in rain. But you see the contrast in the temperatures by the colors. Look at this purple coloring now over Nebraska and the central U.S. There's a large difference in temperature between these 2 areas. That is indicative of the Arctic air that's now, look at this really magenta or the violet color here over the Pacific Northwest or actually western Canada into Montana. That's very bitterly cold air, folks. And that's just the start of some things going on. So we could see with this system, this is one to watch as far as where the low pressure transfers energy. We could easily see some more in the way of wintry weather with the 13 January system. We're going to have to wait to see what happens with this. I am expecting heavy rain again, higher winds again along the Virginia coastline, milder temperatures, pumping it from the Carolinas into Virginia, working their way up to southern Jersey. All right, now let's examine both the GFS ensemble, the Jeff's forecast as we go out further in time, as well as the EPS European ensemble. All right, first, let me explain what's going on here. The graphics here on the left are going to be your 500 millibar height anomalies. And whenever you see the purples, the greens, and the blues, that indicates below normal or lower than normal heights. Whenever you see the browns and these orangish colors, it indicates above normal heights. All right. Whenever you see the blue and the purple and the green coloring, that's indicative of colder temperatures with lower than normal heights, by the way, and also potentially more stormy conditions. Whenever you see the browns and this brightest maroonish orange coloring, that's indicative of upper level ridges where you typically have warmer than normal temperatures. So, examining the Jeff's chart for 12 January, we see much below normal heights across the western U.S. We see slightly above normal heights in these light orange coloring across the mid-Atlantic up to New England. And then we have this giant brown color here. This is associated with that strongly negative North Atlantic oscillation. That ridge axis is working basically from east to west into southern Greenland and just slightly beyond that to the west. And then we have another really strong ridge axis working its way up into Alaska. So we have two, you almost got like a ridge bridge here between the Pacific and the Atlantic sides when these two ridge axes touch each other. Usually when that happens, you get all these higher than normal heights, this maroon and orange coloring and brown coloring well to the north. You're going to get the colder air to slip underneath these higher than normal heights up here. This is associated with the stretched stratospheric polar vortex. Look at the temperatures anomalies over here on the right. The deep purples colors here in northwest Canada working its way into Montana well below normal. You can see the scales on the right side here in each of these graphics. But these are the temperature anomalies on the right-hand graphic here. Oranges above normal temperatures, purples well below normal, bitterly cold, greens below normal as well. So we got a major area of Arctic air starting to spread southeast on the 12th of January. Look at the Jeff's forecast now for 15 January. We see the green coloring now, it's spreading from northwest towards the southeast. It's now heading into the Midwest, and we have these huge upper level ridges on both sides, Pacific as well as Atlantic, and they are basically merging over the top of these lower than normal heights. I literally could make eyes with these two high height centers here. I could do one here, and I could do one here, and then this little green area would be my smiley face if I like cold weather. Never was good at art, so forgive me for that, but look at the temperature anomalies here for 15 January according to the Jeff's forecast. Bitterly cold, extending from northwest Canada, working its way southeastward into the Central Plains, towards North Texas. Still, we have slightly above normal temperatures all the way up and down the eastern coast. We do have that negative NAO. I'm telling you, that anomaly is higher than normal. These higher than normal heights here in the north, that really can have a bearing, that negative NAO, on our temperatures over time in the east and the mid-Atlantic. Here's the Jeff's forecast for 18 January. Whoa, look at the blue coloring now, lower than normal heights from coast to coast. Okay, we have that ridge axis still existing just west of Alaska into the Bering Sea. We see a little bit of a decrease in intensity of that negative NAO at this point by the 18th of January, now looking as strong. And then look at beneath the higher than normal heights again, the purple coloring, well below normal, bitterly cold Arctic outbreak extending towards the Midwest by this point. And now I'm starting to see blue showing up on the East Coast. So we're starting to see colder than normal temperatures work their way basically from coast to coast at this point in time. Let's look at the EPS charts here on 12 January. Look at this. This is very similar to the Jeff's. Let's compare it. All right, so the Jeff's has more of a north to south orientation of this stretched polar vortex lobe, okay? Whereas the EPS is more northwest to southeast orientation of the polar vortex lobe and the anomalously lower than normal heights. And look at these temperatures. They're bitterly cold on the purple coloring. We still are mild, slightly above normal across the mid-Atlantic on the 12th, according to the European EPS. And then the EPS forecast for 15 January. Oh, wow, let's compare. 15 January, 500 millibar height anomalies. 15 January Jeff's. Okay, 15 January EPS. Very similar in its placement of the lowest, the normal heights in the green. But overall, we have blue covering coast to coast, below normal heights. We got the ridge axis with a negative NAO extending from Greenland westward now. We have that ridge axis north-south across Bering Sea just west of Alaska. We're in business, folks, for some really cold air in the U.S. by the 15th of January. And then look at this, the anomalies, temperature anomalies here on the right. just a crash of Arctic air from northwest to southeast, right to the Midwest at this point. The leading edge of the Arctic front situated in the Tennessee Valley on the 15th of January. Then finally, the EPS forecast for 18 January. This is different now. Let's look at the 18 January JEFs. Notice the difference here? The coldest core of the air kind of pivots west to east. What happens on the EPS? 18 January, we have a anomalously lower than normal height, right, at this location over Pennsylvania and New England. So we have a little more concentration. The colder temperatures make it a little further to the east coast with the EPS as compared to the JEFs. The strongly negative NAO, it's relaxing on the EPS model as well. We still see anomalously high heights and ridging across the Bering Sea towards the Arctic. All right. Now, we're showing you that some change is coming to the Mid-Atlantic, and I'm estimating, depending on which model you look at, JEFs is about the 16th of January. I'm sorry, the EPS is the 16th of January. The JEFs is about the 17th of January for the Arctic air to spread to the Mid-Atlantic all the way to the East Coast. Additionally, we have a very active subtropical jet stream. What do I mean by active? Look at your wind speeds here in knots. Whenever you see the orange coloring, now this is the JEF's forecast on the left, but you see the green and the yellows. Look at this. This is a very strong subtropical jet stream still associated with El Nino. So you got Arctic air basically coming down from Canada, and you're getting these disturbances that are riding further south, and the overrunning moisture in a very cold Arctic air can really produce some wintry weather for the U.S. Over the period from 15 to 22 January. Here is the this on the right here is the 200 millibar winds, or the winds at about 40,000 feet, showing the subtropical jet. Very strong winds associated with the subtropical jet. This is the area to watch here. Okay, on the 20th of January, the 18th of January, the red circled area. These are higher wind speeds associated with the jet stream, and that could set off a storm system. So Arctic air is going to be coming down. Subtropical jet stream is going to remain strong. We have persistent storm signals from the southern U.S. to mid-Atlantic. Again, with colder air in place, we could see a winter storm develop over this time period. Now let's examine the European weeklies. These were released yesterday, the 4th of January. We'll take a look at two snapshots of these. I'm going to start off. This is this one here on the left is 25 January. You see the blue coloring all over the place, okay, coast to coast, colder than normal temperature values. The greens are generally indicative of the central U.S. and Montana up to northwestern and western Canada. The greens are the coldest temperature anomalies, but in general, we have a cold scenario here. We have the warmest or above normal temperatures associated beneath that negative NAO, that North Atlantic ridge. And then over here on the right, the weeklies, this is for 5 February here on the right, guys. Believe it or not, we have below normal temperatures from Florida all the way up the East Coast to Jersey and Pennsylvania for 5 February. There's also colder than normal values out in the western U.S. So it doesn't appear per the models that this cold, once it sets in, is going to break anytime soon. I looked even beyond the 5th of February here on the right for the temperature anomalies, and all the way through the 15th of February, we have below normal temperatures from the Gulf Coast up to the mid-Atlantic. And you know what that means, folks. It's prime time for winter storms at that point, late January to mid-February. So it'd be really interesting to see what happens. Here are the European weeklies. These were issued again for January, just yesterday, 2024. The darker greens and blues indicate well above normal precipitation. Above normal precip, this is 25 January. And then over here on the right, this is 5 February. You believe this, guys? 5 February, look how above normal conditions are as far as precipitation goes. Above normal precip from the Gulf Coast right to the Mid-Atlantic. This is a great sign if you live in the southeast and the Mid-Atlantic. Believe me, late January through mid-February, colder than normal values for the European weeklies and wetter than normal. What does that spell at the coldest climatological time of year? And I know for us in southeastern Virginia, my golden window is 20 January to 15 February for snow events. 20 January to 15 February, and we're looking at this. I will take it. Anyway, moving on to final thoughts now. From all the presentation I've given you to this point, all the graphics, I really believe there's a big battle going on between the teleconnections over the next 10 days. Here's the battle. Okay, if I were to go to a boxing ring, I'm going to put all these fighters in the ring. We have a strongly negative let me go back to this. First of all, we have a strongly negative AO. That's indicative of that stretched out, weaker stratospheric polar vortex. That favors cold in the east. We have a strongly negative NAO, Greenland block working its way westward with higher than normal heights over the top. So negative AO, negative NAO, I didn't really throw on the negative EPO because that's also a cold factor for the east. I could have thrown the negative EPO on for a little bit. Versus a milder MJO look. So we have two villains of cold weather in the eastern U.S., what I'm looking at right now. We have the milder MJO look potentially going into phase 4, maybe even 5 by the 19th of January. And then we have that negative PNA, Pacific North American pattern, which favors troughing in the western U.S. Okay. So there's a big battle that's going to be going on between these teleconnections, honestly. There will be initial resistance to the major Arctic outbreak making it to the East Coast through the 15th of January through mid-month due to these specific teleconnections, due to this milder potentially MJO look and the negative PNA. And ultimately, that negative NAO is going to become more west-based, and so those higher than normal heights are going to work their way west to Greenland, and this is eventually going to allow for the Arctic chill to reach the mid-Atlantic at some point between the 15th and 17th of January. Initially, you might be cringing at seeing all these cutter storm tracks in the Midwest and Ohio Valley. That's going to place the mid-Atlantic in the warm sector of the storm systems. The next two storms, 9 and 13 January, look fairly mild in the warm sectors with heavy rain and wind. Now, there could be flooding associated with that rain. We could see some damaging wind gusts, specifically with that system on the 9th of January. A little too early to tell still on the 13th of January. We're 8 days out for that. Again, let's watch the trend of that. That one I think would have more potential for wintry weather, perhaps, if the Arctic air moves in and gets a little bit more closer than what the models are depicting now. Additionally, we have strong damaging winds and flooding rainfall. That cannot be ruled out for the mid-Atlantic, specifically the coastal areas of Virginia, the Carolinas, or right on up to Maryland. Once this colder air gets to the eastern seaboard, the 15th to 17th of January, let's closely watch the potential for a significant storm system to develop off the southeast coast between 18 and 22 January. This is the reason I'm literally pulling it from research that's been done from two amazing people, Paul Coast and Louis Uccellini. They discovered, looking at analyzing all the northeast snowstorms over quite a considerable length of time. They looked at this in this book. They significantly mentioned significant winter storms are most likely to occur when you get a strongly negative NAO relaxing, which it fits this above timeline here, this 18 to 22 January. The stratospheric polar vortex is forecast to remain weak and elongated or stretched out over the next 7 to 14 days. That's going to favor colder temperatures when you have a stretched vortex into the eastern U.S. But right now it appears per modeling it's going to start in the western U.S. before oozing or moving towards the east, that stretched vortex and colder air. And then finally, the EPS ensemble is looking quicker right now. That forecast model with the cold air reaching the east coast around the 15th of January versus the Jeffs ensemble around the 17th of January. So we have a little difference of opinion. The EPS is also colder with the temperature anomalies for the east as compared to the Jeffs. And then latest European weeklies show colder than normal temperature regime for the southeast and mid-Atlantic in early to middle February with above normal precip. Guys, if I could just make sound effects here, I'd go ching ching. Climatologically, this is the coldest time of the winter, late January. Plus, you get climatological peak for snow chances for the mid-Atlantic. This could be an interesting period of time. We're just going to have to watch how all the teleconnections, how they change over the coming weeks. All right, that wraps up the video this evening. I know I've been tardy. I know I've been late. It's been a while since I made a video, but I finally decided to cut one here. Heck, I think the last video I made was on the 19th of December before Christmas. My goodness, where'd the time go? Anyway, that's all I got for this evening. Hope you enjoyed this presentation. And, I'm really excited. I think there's potential coming up with the Arctic shot, and then we get that active subtropical jet. We could really cash in on something if the timing works out. All right, that wraps things up. Spot on weather. Thank you for subscribing to my channel. And until next time, take care and God bless everyone.